Assalamualaikum warahmatullahi taala wabarakatuh and a very good day. Thank you very much, Masters of Ceremony, for your kind introduction. So today I'll be giving my sharing on the topic of shaping the future through progressive robotic exploration and innovation. My name is Ahmad Atif Muhammad Fauzi, the head of Actuator and Automation Lab, as well as the director for the Center for Artificial Intelligence and Robotics, or in short, Cairo UTM. Allow me to give a brief introduction on Cairo. We have two offices, one in Kuala Lumpur and the other one is in Johor Bahru. We have 8 members at the moment. 4 of us are in KL again and another 4 in Johor Bahru. And our main area of research as well as activity is in the area of AI, control and automation, as well in robotics and mechatronics. We was awarded as one of the industry forward competence center in 2019, sorry, and we have a good facility to conduct training as well as some of the research in the area of robotics, and also we have some drones in these smart manufacturing setups. Later, I'll be sharing on this setup as well. So as the computer center in AI and robotics, our vision is to be the leading center for good of mankind in this area. And the mission is to develop frontier intelligent system for industries to promote and disseminate knowledge. And I believe that this session is a good platform for us to share some of our experience together and how these solutions can be benefit to the society. So today I'll be sharing some of the work that we have in National Robotic Roadmap, as well as the involvement of Cairo in the area of field robotics, agriculture, healthcare, and smart manufacturing. Okay. So my personal research area, okay, because we have few members with different areas, I'm involved in the area of bio-inspired robots, where we are developing robots that mimic the God-created creatures like ourselves, animals, and so on. I'm also involved in the area of field robotics, which look through this 3D job, so dirty, demeaning, and dangerous work. And in this third area of rehabilitation robotics or biomedical related solutions. And the fourth area is in biodiversity. And in project 1 or the area 1 and 3 involve mainly soft-based actuators or soft robotics that I will also explain later. And here in this blue box is highlighting the fundamental aspects. So some of the students who are involved in masters or in PhD, so they are working in this particular area. In 2030, okay, to start with, we Malaysians are having our goal towards shared prosperity vision in 2030. And within the goal of 2030 shared prosperity vision, there are 3 main shared prosperity point, which is the equitable growth, sustainability, as well as inclusiveness. Okay, and these 3 main points is very important to bring our society of Malaysians towards the high-tech nation. And this is also fall under the National Science, Technology and Innovation Policy from this year to 2030. So where are we now in terms of the innovation as well as in the progressive in the area of robotics? So we can divide this into 3 different sections. The first one is on innovation itself. Second one is on knowledge, and the third one is on talent. I believe some of the students are also eager to know how is our talent management in Malaysia. And maybe we want to talk about some of the mismatch between the industry expectation as well as the academia kind of supply. So we have the innovation of Malaysia ranked at place of 33rd out of 133. And we can see that the area of innovation is quite, in high quartile. However, if we look at the GII on the Global Innovation Index, our IT or the intellectual property is not yet as compared to the advanced country. Okay, so and secondly, on how we want to see that those IP can be used towards real commercialization. Okay. And secondly, if we look at knowledge, I mean, most of the institution in universities or maybe from polytechnic, so we have a good increment of research outcome or research output in terms of publication, and we are still working so that we can be part of the pioneer in the top 10 citation percentile. Okay, and although we have a good numbers here increasing from years to years, we want to see the implementation of this knowledge towards the applied research as well. And in terms of talent, we have this IMD World Talent Ranking of in 2019, where we are ranked at 22nd out of 63. And this is what I have mentioned earlier, that the talent is very important to be part of the supply part, and how the government will be helping our talents so that it will be as part of the Malaysian uh, limestone ataupun batu permata to be the future leaders in area, especially in robotics. So we see that robotics is going to be part of the key driving technology in 21st century and also in the future of the advancement. And the IFR, International Federation of Robotics, have divided robotics into two main categories. The first is the service robots, and the second is industry robots. And within service robot, another two area of domestic and professional. And the total of this sales I mean, close to 48 billion USD dollars. So it is going to be increased. However, if you want to look at how Malaysian to be compared with other countries, the Malaysia robot density is quite lower compared to our neighboring country. So we have around 45 unit per 10K employees in 2019, and they have around 800. Okay, and the increment of 1 year is quite big compared to us. We have increased with 10 unit. However, for Singapore, they have increased nearly 100 units. Okay, so we can see also the latest data later on 2021. So the global trends on robotics, if you want to talk about applied area, so it is falling under many categories. We can see in healthcare, manufacturing, food agriculture, sensors, mostly in smart manufacturing as well. Security, surveillance, we are doing some of the work here. And we also have robotics in logistics and automation. And we see that most of the advanced country, they have their own robotic roadmap, or maybe the country vision. And in Malaysia, we are still not having our own roadmap. So that's why we're trying to see how the available statistics, especially on the automation readiness index, although we are at the rank 14, so we want to see how we are going to be at par with other countries, especially to assist the startups and also the development of new technology, because robotics is still quite new in Malaysia in terms of how we can come up with our own solution, because normally we're going to take it either from China or maybe use some of the industrial robot from Germany. So this should be including support from government to assist programs, especially for funding some of the technologies. We can see also some of the support that we want in terms of providing assistance in our tertiary level, university, polytechnic, and also to provide seed financing, okay, to the startups. So as I have highlighted earlier, in Malaysia, we are still yet to have our robotic policy, and that is where the discussion under Academic Science Malaysia, together with some of the robotic experts, to come up with our national robotic roadmap. And actually, we are at the final stage of compiling all the data, and hopefully we can use this data and also the policy to assist our talents, especially in the robotics area, to be performing, okay, towards the progressive of our country in this area, robotic. So we put under 6 of these points under the National Robotic Roadmap, and talent, research and development, commercialization and innovation are among the main part of the robotic roadmap itself. So I would like to share some of the contents that we have in the robotics journey in Malaysia. Roughly, we started back in 1990s, where we have among two of the universities, UTM and IIUM. UTM started a little bit earlier than IIUM, but roughly it is in the same year. And we have Cairo to be one of the earliest center in 1997. So roughly now we are more than 20 years in providing solutions in AI and robotics. And now we have a lot more solutions and also companies coming in to assist in the area. And here in 2021, we are working together for the National Robotic Roadmap. And this is under mostly at the moment with the assistance of ASM. So for today's session, I will be sharing some of the technology that we have in Cairo, as well as to introduce some of the work that could be useful as part of the awareness in this program. So to start with, we want to highlight again what was mentioned by IFR, International Federation of Robotics, where we have these two main category of industrial robot and also service robot. So they may have 3 degrees of freedom or more to assist in fabrication, manufacturing, and so on. Whereas in service robot, anything which is excluding industrial automation, okay? So these are considered service robot. So to show you an example, so this photo represents the condition in the manufacturing line, I think for car manufacturing. And this is example of a vacuum robot serving in the shopping mall. And we have a different kind of new robots which is available. So this is example of a Boston Dynamic robot called as Stretch that is having a platform, a movable platform, which is quite different between the old version of robotic arm here. And we have this Atlas robot, okay, that can move around and also do jumping. And I think the most important part for this Atlas robot, I think, is for the motion of the robot, okay, and how it jumps. And here is one of the most interesting part where the robot itself can do backflip, okay. Even I cannot do backflip like this. So this involves a lot of controls, algorithm, and so on. And we can see that initially most of the roboticists learn on how to develop robot inspired by God created creatures. Allah SWT created animals, humans, and so on, leaves, trees. So based on these available structures, then we try to imitate and learn on how those kind of movement can be used in some of our applications. So we have snake-like robot for surveillance. We have like vacuum cleaner using this scrap motion and so on. So Kei Suzumori is my sensei. So he wrote a book on why robot look like living creatures. Okay, and even eventually, yes, we are learning from living creatures that was part of the inspiration in robotics. And we have the category of hard robotics, which is using metal structures like this. And as I've showed you earlier, the Boston Dynamics development of robot, we can see that this hard robot is having rigid material, higher precision, and higher speed. Whereas for soft robots, okay, I think most of you may be quite new in soft robots. So we have this example of Baymax from the Big Hero 6 movie, and the structure itself is quite different from the previous hard robot. We have it more simpler, compliance with human, for example, and having higher water resistance. So this is part of the advantage of soft robotics. And this kind of technology can also be used in certain area, for example, in healthcare. Okay, so and I would like to show some of the examples of soft robot around the globe. One of the company, Festo, they have developed this elephant arm, robotic arm, And the technology that they use for this robotic arm is air-based, okay, pneumatic-based source to do manipulation. And the gripper here is the actual gripper. This is me when I have experience to visit them in Germany. So we can feel the material that they are using additive manufacturing. And uniquely, they also use the same method to develop their own gate, okay, in Festo. And we see other than Festo, some of our researchers, this is from Japan, my sensei, they are developing robots using pneumatic artificial muscles. Some of the development is using balloon type actuators, and some of the others are working with chemicals, okay? So these are examples of soft robot around the globe. And one of the things that we do in our lab is partly collaborating with the Japanese collaborator from Tokyo Institute of Technology, is using this thin McKibben actuator. I will show you some of the work that we have. So this is a different kind of robots that we develop using the actuator. We develop human-like robotic hand. This is another study that we use to mimic the robotic neck. And one of the work that I did when I was in Japan on six-legged big robots, okay? I can show you some part of it. So we call this as lightweight and long-legged hexapod Giacometti robot. So the compartment is having 24 valve on top. It looks like a spider by itself, but then it is very, very lightweight. And we have these few pneumatic bottles, I think, for those who are joining robotics competition. So you have some sources of air coming from bottles, right? As it is lightweight, it is easier to move from one place to another, how it can be used in different terrain. And partly one of the important point that we want to highlight is if we have casualties, okay, of robots, so the damage will be not as big as the heavy robots, okay. So it is not serious damage, and it can work back to the normal with minimum errors or maybe the minimum damage. So it can still work after minimal recovery. Okay, so this is some of the experience that we have with this muscle, and we are trying to work with this material of soft McKibben in different application. Later I will show you. Okay, the first area of robots that we want to highlight is in healthcare area, where we can use robots to do many things, especially in this COVID environment, on how we can use cameras together with artificial intelligence to do detection. And this is a work that was presented by Dr. Ibrahim to do movable camera detection, and it's like a glasses that we can wear around. Dr. Yong developed his mobile-based structure to assist in MIPES, Serdang, for helping doctors delivering food, communicating with patient, and having less contact with the patient. And we have also UVC-based robots that we have developed earlier. This is the first structure, and this is the structure that we are trying to commercialize for a fully autonomous system. And hopefully this is going to be part where this robot can be used in clinic, in hospitals, and also in offices, mosque, transportation means, and wherever we can use UV as part of the solution to kill some of those viruses. In healthcare as well, we have robots that can be used for rehabilitation. We have also using robots, soft robots, okay, to assist in the minimally invasive surgery. Okay, so the open surgery will be having a bigger cut, whereas minimally invasive surgery will have a smaller cut. So this is where some of these actuators can help in doing some of the manipulation inside. So here we work with a different kind of soft material, and this is part of the validation where we do simulation-based analysis, and later on we fabricate. Okay, so this is some of the work that was being done by some of our students. Finger musculature robot for helping on pinching motion. We have studied all the anatomy of hand, and later on we see how we can also develop and mimic those hands and study the application of rehabilitation using actuators like this. And with this motion, we can have, we call this as CPM, continuous passive motion. So one arm will be the master and the other arm will be the slave. And using this concept, we can develop autonomous movement. Like for example, the patient just relax and then the actuator will help the patient to move. So this is called as CPM. And in the healthcare, so this is the new, design that we have for assisting the wearing process. So that it is not as difficult as wearing normal glove. So we just use magnetic connectors to quickly attach and detach the material with the hand. It's like a glove. Okay, in healthcare also, we also work with robotic to help in ankle foot orthosis. So this is some of the work that we have combining actuators, sensors, microcontrollers to assist the patient in walking. Okay, um, so you see in healthcare, there are a few areas that we have involved. And importantly, the robots that we have developed is in collaboration with those doctors or maybe practitioners in healthcare. And that is very important because we have to validate our invention with the experts. Okay. So next, I would like to highlight on smart manufacturing, where we also use robotics to do defect inspection with AI. And this is very important in some of the um, manufacturing line to do detection, analysis, and to have accurate fabrication. Okay. This is an example of using robotic arm to analyze and also to optimize some of the movement. And here we have cobot or collaborative robot to be used together with human. All right, by Professor Fauzi. This is from Dr. Zul, and the area that he worked is the AI together with warehouse management. Okay, AI to do detection of human, to do detection of goods, and later on we can predict the time to move, the better work process classification, and then the overall warehouse management. For me myself, I have also experience in we call this as telepresence, where we work with virtual reality. So the master moves, the movement, and then the robot will be following directly. And this is one of the showcase that we work together with Ericsson to highlight the potentials of 5G. Okay, in robotics. So we demo it to our previous Prime Minister Tun Mahathir in 2019. So this is another smaller version of the robot that can do mimicking of the process. Okay, so yeah, we can think of what kind of application that we can use using this kind of technology. So in smart manufacturing, I think Dr. Yong is also working hard in his spin-off for different kind of solution in manufacturing world. Okay, so moving forward, so we already covered healthcare, smart manufacturing, and now we go for field robotics. So in field robotics, some of the work we do inspire with lizards on how salamander is moving, and we try to develop some of these field robots to be used to get data, for example. And some of the robot here are developed either on ground or we test it inside water. And we also have another uh, um, snake-like system, okay, inspiring by the movement of sinusoidal movement. So here we can see this is not using a single motor, no motor involved. So we have only soft actuators to come up with this kind of motion. And maybe the construction will be cheaper, water friendly, and hopefully it can be used later in the actual field data collection. And we have different kind of materials. This is part of soft actuator where we can use soft actuators to do manipulation like this. So no motor involved in this kind of work. And the idea is to have a longer version of actuators that can do search and rescue operation using this soft material. Okay. And we are also working with different kind of actuators, combining soft material as well as the hard material like this one. So moving forward, in field robots, we have this Inspecto. I think some of our PSAS member have already looked this. know well about this robot. So we use this robot to do maintenance in ducting area. And if the maintenance in duct are not maintained, so normally when we come to work, we have this kind of headache, respiration problem. So whatever situation, we call this as sick building syndrome. And the value proposition of this system that we are developing is to assist in doing the maintenance of cleaning as well as inspection. So we come up with this robot that can do both inspection, like this one, we can do also cleaning, and later on we can have LiDAR to do the autonomous mapping as well as autonomous inspection. So this is how LiDAR works. So normally LiDAR will be having the sensor to identify the area. And from here, once we have already mapped, then we later on can do the autonomous movement. Okay. So we have a good experience last time with in PSAS on doing some of the experiment like this. And then for field robot as well, okay, we have to validate. Okay, I think the main important in field robot work is to validate and talk with the customer. So this is where we come in, do some demo, and also conduct some real experience for the user to feel and touch on how to navigate and so on. Okay, and this is the example of the actual footage of the inspection process where we can identify if there are some impurities available inside the duct. This is quite clean. Some of the duct which is dirty, so you can see all the dust are available inside. Okay, all right. So next, so normally when we put together as commercialization, we want to see how it can be used later for different kind of solutions in hospital, hotel, institutes, and offices. And here is the roadmap of the product where we have starting. I think this is one of the things that I would like to highlight here. Most of the robot that we come out is not directly coming at this end at stage. So we started with a very simple design. You can use chopping board, you can use acrylic. Later on, you improve, and we can validate it to the needs from the industry. So it goes the same with the second method of robot that we're developing for underwater. So here the goal is to clean the water utility tank, not by manual cleaning where you have to drain the water or using a professional diver, which will have a risk for the safety. So here we can use robots to do continuously, okay, without disrupting tiada bekalan air terputus and so on. And the other one is for aquaculture tank. We have shrimps, aquacultures, and normally cara cuci sekarang is quite labor intensive. Many workers need to be coming and cleaning. So how robotics can be used for the autonomous cleaning later. And the value proposition that we would like to highlight is safe operation, faster in setup, no water disruption, and cost-effective solution. So here, how robotics come in, and this is an example of the actual cleaning process. Nobody is coming in, so all are robotic based. Okay, and this is the latest design that we have for the underwater ROV for inspection as well as for cleaning. And this is some of the movies to highlight how we do the cleaning process, comparing the water quality before and after, and so on. Okay. And yeah, we have a lot of tests and also validation process, as I've mentioned, so that we can confirm what are the feedback from the customers. Okay. Okay. Again, we are looking at different kind of solutions. Water tank is part of it, water pool in hotel, agriculture pond, and these are example of some of the demo session that we had earlier. So the project of ROV is much more earlier, so you can see how difficult in developing robots and bringing it together to market. So currently we have this unit and trying to see how it can be commercialized in some of the solutions for water tank cleaning as well as in aquaculture cleaning. Okay, I believe this is the last part of area that I would like to highlight. We have covered healthcare, smart manufacturing, as well as the smart manufacturing, field robotics, and agriculture. So in Cairo, we have some of the work that we use for exoskeleton. We have calf monitoring using sensoring technology, and also this is the most important thing. In agriculture, we can deploy AI as well together with robotics, and with AI, we can do object tracking. We can also do object counting. So, for example, having a camera to analyze how many cars moving from left to right and how many cars or vehicles moving right to left. So, this is important in when how we integrate together with AI, identifying different kind of vehicles, truck, cars, and so on. And again, another technology that we can propose with our ducting robot. So if we have some impurities inside the duct, then we can know that these are something which is not properly available. So you have to do reporting, and AI can help. Okay. So we have worked with WWF, Department of Fisheries, using AI to do detection for turtles, and here we use underwater robot to do observation. Not only turtles, we have a lot of endangered species that we can assist using AI. Okay, come back to the area of agriculture. This is where we have drones, flying robots that can be used. And by using the technology of AI, we can use it together with drones to do livestock counting. So counting how many cows available, we can count kambing ke dan sebagainya. And we can use this for vegetables, understanding how many bananas that have been wrapped, ada lagi yang tak wrap dan sebagainya, and some of the study on diseases of plants. Okay, mungkin ada padi tadi kan. And here we can also use AI with drones to do asset monitoring. Okay, this is the work by Dr. Zul on looking fences that is still functioning and those who are not functioning. So it's quite tedious nak jalan kaki macam ni. So by using drones, we can speed up the process. Okay, so last but not least, before I go, I think the time is quite limited. We have this program of upskilling and reskilling under the Industry Forward, where in Cairo, we are trying to highlight this Industry 4.0 pillars, and we are working together in these three main areas. So this is where the Cairo Intelligent Manufacturing Lab, as I have mentioned earlier in the slide, to assist on the technology that available, the smart manufacturing line, using different kind of robots that we put together in this 4 module: the production module, assembly module, drone delivery system, drone delivery module, as well as the storing and retrieval module. Okay, and this is where drone also are being used to carry goods, to transport from one end, one compartment or one module to another module. Okay, and this is quite interesting, where you can see everything inside the lab is based on robotics motion. So we have here the assembly line, where this is using CNC machine, and we have also 3D printers to do the additive manufacturing. Everything is controlled by robotic arm, and we have here the assembly line. This is fabrication line. This is assembly line to assemble some of the parts. And drone are going to be flying over to bring the compartment with this station. This is the robot that we are going to develop, 3 degree of freedom robot, to be manufactured in this line. And to close the session, I would like to highlight that the government is proposing this 10-10 My STIE, okay, 10-10 My STIE framework under MOSTI, where robotics could be adopted to achieve progressive, prosperous, inclusive, and sustainable high-tech nation by 2030. So we have the 10 economic drivers, and then we also have the 10 technology that we can use and also explore. And we can see how robotics framework can be coming in to assist in this socio-economic area. So there is a lot of catch-up current technologies that is being proposed. For example, autonomous robot for submarine. We also have autonomous unmanned ground vehicle for last mile resupply and medical robots and so on. And we also have the leapfrogging technologies, some of the technologies that we're going to come out. So I believe we can have this document coming from the Academy Science Malaysia as towards the future of robotics. Okay, so before we go, I would like to highlight this saying by James Lovell. There are people who make things happen, and there are people who watch things happen, and there are people who wonder what happened. And to be successful, we need to be the person who make things happen, and together we can succeed. Okay, for the betterment. So with that, thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.